Now consider again dividing this network into two equal subnetworks. Let organization A be assigned with a classful address 200.10.10.0 and the network administrator wishes to divide this network into two equal subnetworks. So first of all, we shall identify to which class this IP address belongs to. The first octet shows that it is a class C address and hence the first 3 octets or the first 24 bits identify the network. Now in order to divide this network into two equal subnetworks, we shall borrow 1 bit from the host identification portion. This bit can be either 0 or 1, so we shall fix it to be 0 for subnetwork 1 and 1 for subnetwork 2. The subnet 1 IP addresses are having the first 25 bits fixed to be 200.10.10.0. With remaining 7 bits, there are 2 power 7 possible combinations and hence there are 2 power 7 possible IP addresses belonging to subnetwork 1. Among them, the first IP address is used to address the subnetwork and the last IP address is used as the directed broadcast address for the subnetwork and the remaining 2 power 7 minus 2 addresses are used to address the hosts. So the address of subnet 1 is 200.10.10.0. The address of subnet the directed broadcast address for subnet 1 is 200.10.10.71. 7 ones is 2 power 7 minus 1, 128 minus 1, 127. The number of hosts that can be addressed within subnet 1 is 2 power 7 minus 2, 126. Similarly, subnet 2 IP addresses are having the first 25 bits fixed to be 200.10.10.1. With remaining 7 bits, there are 2 power 7 possible combinations and hence there are 2 power 7 possible IP addresses. Among them, the first address is used to address the subnet 2. The last address is used as the directed broadcast address for subnet 2. Remaining 2 power 7 minus 2 IP addresses are used to address the hosts. So the address of subnet 2 is 200.10.10.128. The directed broadcast address for subnet 2 is 200.10.10.81. 81 is 2 power 8 minus 1. 256 minus 1, 255. The number of hosts that can be addressed within subnet 2 is 2 power 7 minus 2, 126. So we can see that within a class C network, the number of possible IP addresses is 2 power 8. Among them, 2 addresses are reserved, one for network and one for directed broadcast address. So the number of hosts that can be addressed within a class C network is 2 power 8 minus 2, 254. But now, when we are dividing the network into two equal subnetworks, instead of 2, now 4 addresses are reserved. So the number of hosts that can be addressed within the class C network as a total is 2 power 8 minus 4, 256 minus 4, 252 hosts. 126 plus 126, 252 hosts only can be addressed. Now suppose the network administrator divided the network into two equal subnetworks and connected them with a router. And suppose a packet is received by the router with the destination address 200.10.10.132. We can represent it in binary format. The leading bits in binary format 110 tells the router that it is a class C network. The address is 200.10.10.0. But within this network, the packet can belong to either subnetwork 1 or subnetwork 2. So to which subnetwork this packet should be forwarded to, or to which subnetwork this IP address belongs to. To realize that the default subnet mask never works, we need the help of some explicit subnet mask. We know that subnet mask associated with the IP address helps to identify what part of the IP address identify the network and what part identify the host within the network. And the subnet mask consists of all ones in the network identification portion followed by all zeros in the host identification portion. For a Class C network, the first three octets identify the network. Hence, the first three octets or the first 24 bits are ones followed by 8 zeros. Now, when we divide a Class C network into two equal subnetworks, we are borrowing one bit from the host identification portion and are adding it to the network identification portion. So now, instead of 24 bits, 25 bits identify the network and the remaining bits identify the host within the network. So the subnet mask consists of 25 bits ones followed by 7 zeros. So the new subnet mask is 255.255.255.128, and since we are dividing the network into two equal subnetworks, the subnet mask remains the same for subnet 1 and subnet 2. Now this subnet mask will be kept by the router. Whenever a packet is received with this destination address, in order to identify to which subnetwork this packet to be forwarded to, the router performs a logical AND operation with the subnet mask. By performing a logical AND operation between the destination address and the subnet mask, the network address portion from the destination address can be extracted. The subnet mask shows that the first 25 bits followed by all zeros is the network to which this IP address belongs to. It means the network address is 200.10.10.128. It means this IP address belongs to the subnet with the address 200.10.10.128 and it is the address of subnetwork 2. So this packet will be forwarded to subnetwork 2. So in order to divide a classful network into two equal subnetworks, first of all identify the class to which this address belongs to. The first octet shows that it is a class C address and hence the first three octets identify the network and hence the subnet mask, the current subnet mask for it is 255.255.255.0. Now, in order to divide this network into two equal subnetworks, we should borrow one bit from the host identification portion and accordingly we should apply the new subnet mask which will be 255.255.255.1 followed by 7 zeros, which is actually 255.255.255.128. Thus, we can have two subnetworks, one with the address 200.10.10.0 followed by all zeros and the other with the subnet address 200.10.10.1 followed by 7 zeros. This is the subnet with the address 200.10.10.0 and this is the subnet with the address 200.10.10.128.